get started on another geometry lesson. Oh, sorry. The nice thing in Math Heaven is I don't have to break your heart. We get to do math. Yeah, right. Okay, so last time we were learning about how to prove lines are parallel, and we learned there's 4 ways. Just recap that real quick. We learned that if you could show that the corresponding angles are congruent, or the alternate interior angles are congruent, or the alternate exterior angles are congruent, or the consecutive same side interior angles were supplementary. Those were the 4 ways. Well, today, as I mentioned yesterday briefly, we're going to learn the traditional way that you learned in algebra how to prove that lines are parallel, and that's just basically by using the slope of a line. So this, for the most part, should be reviewed because you should know how to find the slope already. You've done that before, I'm sure, from algebra class. So let's get going on it. And this builds up for the next lesson, 3.5 as well, lays the foundation. So it's something we've got to definitely be able to do. So our objective today, students will be able to find and compare slopes of lines. Turns out there's some special slopes that you need to know, and you should memorize some of the special ones. How do you find the slope of a given line? Giving coordinates of 2 points on a line? Well, just use the formula. It's pretty easy. Alright, so slope is defined as the rise over the run. Typically we use this equation here, y2 minus y1. That's the up-down direction divided by the horizontal or left-right direction. So think of it as a change in y over a change in x. Sometimes I just might mention here, it's also referred to as a rate of change. Like how fast something is changing. Often we talk about speed. That's also a rate. It's the amount of distance you cover in a certain amount of time, usually like miles per hour. So just keep in mind, sometimes you'll see various words and various problems and applications and so on and so forth that involve slope. Slope comes up quite a bit in construction because of safety reasons. The roof, for example, for your house could only be certain slopes. Wheelchair ramps can be only certain slopes and so on and so forth. So it's probably a good idea to understand some basics about slope here. Well, there's a little picture that illustrates the formula. This y2 minus y1 is the change in the direction in the y direction. This x2 minus x1 is the change in the x direction. And remember, it's the rise that goes on top and the run on the bottom. People sometimes get these two flip-flop, and that leads to mistakes. So alright, so there are some special slopes that you should know of, and I would know all 4 of these situations. This first one says if you're going from left to right. Notice it's always from left to right. Okay, as you're moving from left to right. So if we're on line J, there's a point here, and we're moving along this way, and we're actually going down as we go from the left to the right. As we're sliding along this way, this line actually goes down. Okay, so it has what we call a negative slope. On the other hand, if we go up as we go from left to right, as if line K, here's another point here, and we're now, as we go from left to right, we're going in this direction. We're actually going up this line, continuing to go upwards, and so naturally we have a positive slope. If there's no change, like neither goes up or down, then we'll say that we have a zero slope. And that's the scenario for line L. we have a point here, and it doesn't go up or down. It goes just straight, so to speak. Now this one's also straight, but it goes straight up. Straight up. This one going straight up here. Passes through this point and this point here. This is what we call a vertical slope. Okay? And we're going to say in that vertical case that it's undefined. Now, I'd like to briefly describe to you why it's undefined. So, what we're going to have is, remember that slope is equal to the rise over the run. And the run is like this direction, right? And the rise is that direction, right? So if you wanted to, you could measure a certain distance here. You could say, like, for example, we rose 8 units up this way. And so on this slope, we'd say, well, the rise is 8. But how far did it go left and right here? Well, from this point to this point, it didn't go any direction. So you're dividing by 0. And you'll remember one of the first commandments of mathematics is that thou shalt not divide by 0. Well, we say that is undefined. So the natural question is, why is it called undefined? Well, because it's a number that we can't pinpoint. We can't. This number, this is actually equal to some strange number, but we can't pinpoint its location. Like, where is it at on the number line? And it's actually a number that we call infinity. And so that number, we can't tell you where it is on the number line, because we could say, well, it's way over here. It's like right over here. But actually infinity goes on and on and on and forever. And so it has like no stopping point. So when you're on a number line, like 0 being here, and this is like this really big number, infinity's way beyond this point, and it's way beyond that point, way beyond it. It just keeps on going forever. So that number is undefined. Now, are you convinced? Why is 8 divided by 0 undefined? Well, if you do this in your calculator, you can see what happens. Okay, so the question is, let's just do this real quick. Okay, I'll use a calculator. As you get close to 0, we would get to like 1/2. Okay, that's getting closer, so we're going this way. We're getting closer and closer to 0. Eventually, we get to a location here that's called like 1/10. Okay, and you could get even closer in there, and you get into eventually to a spot called 1/100th. Okay, and you could even get closer than that and get to 1/1,000,000th. Okay, that's getting pretty close to 0. Well, so now let's take a look at what we're doing now. If we take 8 and we divide by that number, remember we're dividing by 0, right? But instead of using 0, let's use these numbers that are really close. So if you use like if you use 1/10 down here, you know what you get when you take 8 and divide by 1/10? It's actually equal to 80. And you know what you get when you get 8 and you divide by 1/100th? Try this in your calculator. It's a little tricky, but you actually get 800. And if you were to divide by 1/1,000,000th, and you take 8 and divide by 1/1,000,000th, 1/1,000,000th, actually what you get is 8 million. Okay, so if you could just imagine this, the closer we get to 0, the ratio of 8 divided by some number that's getting closer and closer to 0, these numbers are getting larger and larger and larger. And so what we say is that that number is getting so big and it's getting larger and larger, we say that it's going to infinity. The number is undefined. So that is why, first of all, we can't divide by 0. It's undefined. But that is why it's called undefined, because it's equal to infinity. And infinity is not a number that's defined. There you have it. Now you know. And you'll never be confused with that again, right? Right. Okay, so many problems that you'll have on your study guide and homework will be like this, where you have to find the slope. And as long as you can use the slope formula, whoops, let's back up, sorry. As long as you can use your slope formulas, this should be no problem. We're going to find slope A. So I'm going to use little subscript A. But remember, we need to use the formula y2 minus like y1. Divide that by x2 minus x1. So subtract the y coordinate, subtract the x coordinates. Okay, so line A. Line A, I need to use 2 points that are on line A. So why don't we use this point here and this point here? So I need to subtract the y coordinates. So let's just go this way. Let's subtract those 2 coordinates that way. Those are the y coordinates. Remember, this is x, this is y, and then this is x, and this is y, and this is my first point, second point. Well, it doesn't really matter which point is which, but anyhow, we need to subtract the y coordinates. So let's try 4 minus 2, 6 minus 8. Alright, now, before I answer this question, or finish this calculation, we know that line A has to have a negative slope, right? Because we're actually going down as we go from left to right. Remember? As we go from left to right, this line actually goes down. Now check out the mathematics in the formula. It should confirm what your intuition is. If we take 4, subtract 2, we get 2. We take that divided by negative 2. That actually equals negative 1. So that sort of matches what our intuition is. We would say that has to be a negative slope, and it is a negative slope, so that's good. How about line D? Line D now, we need to use 2 points that are on line D. Well, we can use, line D is this one, this red line right here. So in this case, we would have slope number D, or slope for letter line D. So we need to subtract the y coordinates. Well, there's my y coordinates. So how about if I go 4 minus 0, and then we need to subtract the x coordinates. What we get is 6 minus 6. In this case, we get 4 divided by 0. Now I just told you what that means. If you take a number and divide by 0, we say that that number approaches an idea called infinity. Okay? It approaches an idea infinity, and that number, of course, is undefined. So we simply say for this case here that the slope of this line, this red line, is undefined. Now, I'm just going to tell you a shortcut here. Usually what we do when we're writing undefined is we just write UND, undefined, like that, abbreviate. Okay, so you're going to have some problems on your assignments where you're just calculating slope and you find a couple points on the line, use the slope formula right here. Pretty easy stuff, not too bad. Okay, so here's our postulate. It says if 2 non-vertical lines are, in a coordinate plane, 2 non-vertical lines are parallel if and only if they have the same slope. And then there's an additional little side note here. 2 vertical lines are always parallel. And so you probably want to memorize this extra little case here. If you have 2 lines that are undefined, their slopes are undefined, then you can say they are parallel also. So in other words, if you had a line here, okay, and a line here, okay, and both slopes, like if you had slope number 1 equal to undefined, okay, and you had this slope right here, slope number 2 is equal to undefined, well then we can turn out and say, oh, well that means that these lines are parallel. Okay, so pretty easy stuff here. It's pretty much what we're going to be practicing is the slope formula. Now perpendicular lines, the slopes of perpendicular lines, they're kind of interestingly related. Turns out that the product of their slopes is -1. Now, most people probably use a little trick I learned a long time ago, and just to use, we just simply use the reciprocal idea. Like you might remember back a long time ago, reciprocals. Like if I have 4/5, the reciprocal would be 5/4. Okay, and if I have 1/3, the reciprocal would be 3/1. You see, so you just flip the fraction, just flip it. Okay, just flip, and that's what happens on perpendicular slopes. Whoops. It turns out that if you calculate, let's just do it right here. Let's say we calculated one of the slopes and we found slope number 1 to be equal to 2/3. Okay, well if I want a perpendicular slope, a perpendicular, that's my symbol for perpendicular. Okay, perpendicular, in case you've never seen it, that means perpendicular. If you want the perpendicular slope, all you need to do is flip the fraction. Oh, but there's just one extra thing. Okay, one of these has to be negative. Okay, because they said the product is -1. You see, and the only way to get a product of -1 is that if one of these is negative. So if you started out with a positive one, then you need to make the other one negative. And likewise, if this one were negative, you'd have to make this one positive. Now check this out. Now it says the product. Now the product means you multiply. So if we multiply these two slopes, I would have 2/3 times -3/2. That's the product. And what does that product equal? Well, the 2's cancel, right? You get 1 here and a 1 here. And the 3's cancel. You get 1 here and a -1 up here. And 1 times -1 is -1. 1 times 1 is 1. And of course this is simply equal to -1. And so you can see, because of the slopes having to have a product of -1, it means the two slopes will have to be reciprocals. And so that's a little secret on how to find slopes of perpendicular line. You find the slope of the first line, and then you just, to find the slope of the second line, you just flip it and change the sign. So you flip the fraction and change the sign. So let's try a problem. Okay, so what do we have here? It says line K passes at a point 0,3 and 5,2. Graph the line perpendicular so that K passes. Okay, so typically what we need is a graph. So it should have a graph here. Alright, now on your study guide, I don't have the graph in there, but you'll just have to create your own. Anyhow, let's go ahead and plot these points real quick, and let's see if we can get a graph figured out. So K passes through 0,3, so K is right there. Okay, and excuse me, line K passes through this point here, and it also passes through 5, 2. There's 5, 2 right here. So line K, let me see if I can get this drawn. Let me see if I can find my ruler here to help me draw this here. Alright, so I'll see if I can draw. This is a little bit hard. Well, not too bad. Okay, so there's, if I make these dots big enough, it looks like this is, oh, that's awful. Oh well, it's hard for me to place it. So this then is this is line K. Okay, so now what we want to have is a perpendicular line. Okay, it needs to be perpendicular, so it's going to go through this direction somewhere, but where does it go through? It has to pass through the point 1, 2. Well, 1, 2 is right here. So we're going to want a perpendicular line, okay, that passes through, well, it almost looks like it goes straight up and down, but that's not a 90-degree angle. In other words, when it crosses, we want it to create a right angle like that. Well, here's the plan. What we're going to do is find slope number 1 first, okay, and we're going to use this point and this point. So there's my X, there's my Y, here's my other X, there's my Y. We'll call this X1, Y1, X2, Y2. So to use the slope formula, I need to subtract the Y coordinates, right? And then I need to subtract the X coordinates. It's supposed to be a 1. So if I take this Y coordinate and I subtract that Y coordinate, I end up with 2 minus 3. Now if I take this X coordinate here and subtract that one, I get 5 minus 0. Now I just need to simplify this. This is going to be negative 1 over 5. Okay, so there's slope number 1. Well, now we need to find the slope number 2 that's going to go through this way. Well, I know the secret. Slope number 2 is simply going to be the reciprocal of this one. So that means it's going to be 5 over 1. And remember, one of them has to be negative, one of them has to be positive. Well, since this slope is negative, that means the other one is positive. So there's my slope. Now what I can do is I can simply just go, well, that's kind of hideous. I wonder if you could read that. I'm going to rewrite it here. 5 over 1. Okay, so there you go. Looks artistic now. Anyhow, since the slope is 5 over run, remember this is rise over run. Okay, rise over run, right? So I can start off with this point right here and go up 5. 1, 2, 3, 4, 5, and then go over 1. You see? And now what I can do, I could start here and hey, that was pretty good. Not too bad for a teacher. Okay, so anyhow, the point is that now makes a right angle like that. How about that? So let's summarize on how to do this. You're going to find slope number 1. There it is, right here. And then you're going to find slope number 2 by just flipping these. Okay? So that's how we got 5 over 1. And then remember, one of them has to be positive, one of them has to be negative. Since that one's negative, this one must be the positive one. So then we take our starting point right here, we'll go up 5 and then over 1. And so then we know that's going to be our perpendicular line. Alright, so you will have to do this on your study guide, and you'll also have to do it on your assignment. So make sure, if you need to, you can review this. Ooh, man, that's ugly. Alright, so here's another related question. Line N passes through 0, 2, and 6, 5. Line M passes through 2, 4, and 4, 0. Is N perpendicular to M? Well, our plan here will be to find slope number 1, find slope number 2, and then what we'll do is we'll just simply we'll find the product. If we take slope number 1 and we multiply it by slope number 2, it's supposed to be equal to -1 if you have perpendicular lines. So that's our plan. So here's, we'll take 5 and subtract 2. That's subtracting the y coordinates. And then we'll take the x's and subtract. We got 6 minus 0. And in this case we get 3 over 6, which is equal to 1/2. So I did everything right. I think I did. Let's see. 5 minus 2 is 3. 6 minus 0 is 6. Okay, so there's the slope of the first one. Well, now the second slope is using these 2 points. So if I take the y coordinate here and I subtract the y coordinate over here, I would have 0 minus 4. And then I take the x coordinate here and I subtract the x coordinate here. So that would be 4 minus 2. Well, that's equal to -4 over +2. And that turns out to be -2. Okay? And I've already figured this out. It's going to be perpendicular because remember the trick is just to use the reciprocal. Well, if I flip this fraction, I'd have 2 over 1. And remember, one of them has to be positive, one has to be negative. So it's negative, and there you have it. It's right there. So, but let's check this out. If you take 1/2 and you multiply it by -2, let's just put a 1 down here. Does it equal -1? Well, the 2's cancel and give you a 1 here and 1 here, but that's negative. So you have 1 times -1. Well, that of course equals -1. So since the product of the 2 slopes is -1, we say the lines are parallel. That's the explanation. Of course, you need to state that out. I mean, you need to write it out in a sentence. So I'll let you do that on your own. So basically, we're finding slopes, and we use the slope formula. And then, of course, perpendicular slopes and parallel slopes are a little bit different, but that'll get you through the lesson.